Welcome back to Legacy Code Unchained. Uh, Today we have Adrien Joly as our guest. And Adrien is a software engineer and tech coach at Shoto, where he specializes in helping people dealing with legacy code systems. And this is why we invited him, obviously. Um, you may know Adrien because of his influential article, How to Regain Control in a Legacy Code Base. I will not try to pronounce the original French title, How to Respect for the French Language. But besides this article, you may also watch several presentations from Adrien. In particular, I would like to mention the presentation that he gave a couple of years ago at MenderCon about decommissioning progressively using AST traversal. I'm very much into AST, so this presentation caught my attention. Then other resources that you may want to look into, of course, is a blog at adrienjoly.com. And in case you speak French, you may also want to watch his podcast, Save de la Tech, hosted with Jeremy Giraud. I hope Jeremy not be offended by my pronunciation. And in general, I think what we are going to learn from Adrien is very valuable because of his pragmatic approach and because what he's going to share is based on his professional experience doing this for a living. So, it's not just theory. And so hopefully at the end of the episode, we will have some concrete ideas to improve our work. So, Adrien, welcome. How are you?
Thank you, Federico. Thank you for having me. I'm great. How are you?
I'm good, and very excited to have you here. And well, let's take advantage of your present, and let's start with the first question. And I always like to start asking about your definition of legacy code. And recently you gave an interview at a podcast, and in this interview, you mentioned that a legacy code is not necessarily code that is old. It could be old, or could be the technologies are old, or legacy code could be legacy because of a lack of documentation or testing, and these factors make you afraid of modifying the code, and that is the defining characteristic of legacy code. So I wanted to ask you, first of all, if I'm reporting your definition correctly, and then maybe to tell us more about this and why do you think, why did you come up with this definition of legacy code?
Yes, sure. I did not personally come up with that definition. I actually stole it from Nicola Carlo, who I believe you know already. And he probably stole it from someone else. And it doesn't really matter. I really like that definition because I think that even if you're dealing with old code or with code without tests or all the things that you mentioned, the problem is going to be quite similar, is that you are kind of stuck in your code base. You cannot improve it easily anymore. And the techniques to solve that problem are also quite similar. It's a problem of rigidity of the code at the end of the day. So you need to rework it in a way that it's unstuck and you can start evolving it again. That's why I like that definition. I think it's broader, it's more general, and it's more open than just saying it's old code. Also, one thing I like about that definition is that it can apply to your own code. One of my experiences as a software developer on legacy code was to rework code I wrote 10 years ago. So it's like I inherited code from myself. I was supposed to understand my own code because I wrote it, but 10 years later, you realize that the code you wrote is not the same that the code you write today. So you have to put yourself back into that mentality, into that mindset. and understand and rework to make it more modern. So again, it's the same problem that you're facing: is how can I get up to speed on that code base that I'm not sure to understand and that I'm quite afraid to update.
Good. And well, so you mentioned already understanding and the fact of regaining control. That is something that you go in depth into in the article that I mentioning in the introduction, how to regain control in a legacy code base, or what I will again not try to mention the French title. If you could share it, maybe.
Oh, the name of the title of the article?
Yes, the French one.
C'est comment rendre un code legacy à nouveau maintenable. This one?
Yes, exactly. I'm very happy I didn't attempt myself. So in this article, well, you mentioned the idea of regaining control. And can you tell us what does it mean to regain control in the context of a legacy code base? I mean, what we need to do in order to get there?
To me, regaining control means that whenever you need to make a change, like for example, you want to fix a bug or add a feature or change the behavior of your code base, you need to find where you need to make that change. So you need to understand the structure of your project. And then whenever you find that place, you need to know how to proceed without breaking everything. Basically, I think that's the two most important points. Because if you're touching some code that is very old and hard to understand, it's very easy to break stuff. And even worse, sometimes you break stuff without even realizing that you broke something. So it means that you may probably make the change, deploy to production, and maybe some days after that, you realize that because of your change, something doesn't work anymore. Yeah. And I think the second part of your question is how to deal with that, how to regain control, correct?
Yes.
I think the basics is, when you go to a legacy code base, or at least a code base that you're afraid of, or a code base that you don't understand, there is no easy way around it. You're going to have to explore. You're like how do you call it in English? An archaeologist, like Indiana Jones, you have to go into the code base and get some things around, and try to figure out what it means, what its structure, how it works, how to install it, how to run it, how to deploy it. And I think the first step towards regaining control is to go deep into that project, try to install it, try to run it, and document every step. Because the deepest you go into that code base, it takes some time to go deep into it. You don't want to spend that time twice. So whenever you do that effort, you want to document so that the next time or the next people who will be involved with that code base won't have to suffer that much. So first step is to install, run, and while you do that, you document everything. And I believe that there are many ways to do that. You can use your debugger. You can use you can ask people who have been dealing with that code base in the past, if you have access to those. They can bring you some hints of where to start. You can look for keywords in the code base. For example, you can look for API endpoints, look where they are located in the code base to figure out what are the entry points of the software. And then in some cases, I think you can use LLMs now, because it's a pretty hot topic, and I think it's pretty helpful for legacy code bases in some cases, because then you may have problem with the context window size. If your code base is very big, it could be a challenge. So yeah, setting things up, running, figuring out what are the entry points. And as soon as you got it running, I guess the next step is to try to deploy it without changing anything, making sure that you're able to deploy it to production. Normally, nothing should break because you didn't make any change except writing documentation. And after that, I guess it's like getting into an open source project. You try to do a very small change that is not very dangerous to do, to start to build that confidence and to discover things little by little into that code base. I guess that would be the first steps. I don't know if you think of other steps.
No, I think it makes a lot of sense to be able, in particular, to reproduce the build per se and to deploy it. Then I think depending on the environment, this could be easier or more difficult. Maybe we will come later to this point, but maybe you have worked specifically with code bases in JavaScript and TypeScript. Maybe for some older technologies, maybe sometimes it's difficult to reproduce the build because maybe you need to access to weird components, maybe don't even run on your hardware. You need special machines. So, but in general, I agree that this is very good starting point. And one specificity that I think I notice in your approach, and I find it's different from maybe what other experts in legacy code do, that it seems to me that you put more attention in the processes and mindset more than maybe underlining, the usage of a specific tool or technique. So do you agree? And if it's, and in case you agree, why do you think that mindset and processes are important when dealing with legacy code bases?
I think that both processes and tools are important. And mindset as well, of course. I think the mindset is the most important because when you're dealing with legacy code, it's very easy to fall into the trap of criticizing the authors or saying, oh, it's too hard, I won't bother, I want to rewrite everything, etc. And I think that in most cases, it's not the right mindset. If the code base ended up that way, it's because there was a need for it, or there were some circumstances that made it that way. And it was nobody's choice to make it a pain for other developers. I mean, developers normally are not sadistic. They don't want to hurt other developers. So probably they ran out of time. They were under a lot of pressure, or they had to make quick changes without the skills or without the right tools to do it. So I think the mindset, the most important thing is to be empathetic towards these people and understanding that they didn't do it on purpose. And yeah, it's not easy, but if you are given time and trust to rework this, take your time and just do things one step at a time. That's okay. If you are given time to do that, you're already lucky, because I think in some cases, I meet many developers that work with legacy code, and the problem is sometimes they don't have time to rework it. So they have to evolve it without making it more modern or easier to work on. And this can become a nightmare. So if you have the opportunity to rework a legacy code base and make it more modern, you're lucky. So you have to keep that in mind. So I think that's the foundational requirement if you're dealing with legacy. Then you said focusing on processes more than tools. I think there are two reasons for that. When you're working in the JavaScript environment, JavaScript is not that old of a language if you compare it to like typical legacy languages like COBOL, etc. It's a pretty recent language, but it already has a lot of history. It evolved a lot. And at the beginning, it was a scripting language. And because it's the language of the web, which is supported by all browsers, it became very popular, and including for new developers who don't have much skills. And this has it's good because it means that now it's a very popular language. When you can do something in JavaScript, you can work in many different kind of industries, which is great. And it also means that we have maybe too many tools and too many ways to do the same things. I mean, there is no normalization. When you say I develop in JavaScript, we're not sure if you're going to do object-oriented programming, or if you're going to do functional programming, or if you're going to lint your code. What tool are you going to do to lint your code? So there are so many ways to do everything in that language. It's a real mess. And same for the tools. They come and go. Sometimes there's a very handy tool, and 2 years later, that tool doesn't exist anymore because the developer lost interest or something, I don't know. And then there's a new tool showing up. So I think it's important in that ecosystem to not be too attached to the tools themselves, but rather take a step back and try to understand in a higher level what we can do, and then find the tools that can help you do what you want to do. And in terms of processes, I think the most important ones, or at least the one I had to deal the most with my clients, was to rework legacy without freezing delivery. I think that's very important. Usually, I work with startup companies, so they have to evolve all the time. They cannot stop. They cannot afford to stop. Especially when you're working for an e-commerce company, for example. Every day that you stop making new feature, or every day that your website is not working, costs a lot of money and brings a lot of risk for the survival of the startup. So you want to be able to rework the legacy and be able to iterate on the code base at the same time. And this is not, I mean, no tool is going to do that for you. It's just a matter of having a plan and iterating on that plan. So this, I think, is more important than having than specifying tools to do the job. And most people don't really know how to do it. I mean, a few years back, I had no idea how to do it. I never learned it at school or anything. I learned it with my colleagues. I learned it with my clients as well, or by reading books. So that's why I think when you are a consultant, you can bring a lot of value because you learn this kind of stuff because you know that many clients have that problem. And because you know that you're going to work for very similar clients, you have an incentive to take the time to learn about these techniques and about these processes. And then every time you go work for a client, you learn something new that will bring even more value for the next client. Sorry, it was a bit all over the place, but I hope it replies to your question.
Very, very interesting. A lot of points that are interesting, in particular, the last point about, acquiring expertise and skills, in every job that you do for the different clients. I think it's one of the advantages being a consultant that is specialized in something, like, for example, dealing with legacy code, and very different from a generalist that, cannot reuse so much what they learn. Early in your answer, you mentioned, sometimes someone has the idea of rewriting the application. Then you mentioned that in many cases, there are deadlines. One needs to deliver new features, and I guess that discourage people from proposing to throw everything away and rewrite it. But I have still the feeling that sometimes some developers has a first reaction, something like, okay, whoever built the application so far was not as good as I am. Let's throw away everything. I'm sure I can rewrite it better in 2 months or whatever. So do you encounter this situation? And if so, what do you tell to these people to convince them not to attempt rewriting everything and instead refactor and improve the application they have?
So far, the experience I have with people who decided to rewrite everything, many times it wasn't a good idea in the end, because the risk that you is that you begin with one problem, which is one legacy code base, and you end up with two problems. One legacy code base that is still alive, and one modern code base that will never ship to prod because it's never ready. And then you have to do a double run, meaning that every new feature must be implemented in the two code bases. So in most cases, this is not a good idea. I think the probably one case where I think it's a good idea is if the functional scope changed a lot. Like if you're a startup company, you had a pivot, you're changing your product so much that the legacy code base doesn't make that much sense anymore. In that case, I think it's okay to rewrite. Another reason why it's usually not a good idea is that when you rewrite everything, developers tend to get excited because they want to put all the new stuff that they couldn't use before. And the risk is that you fall into a hype-driven development. So you want to use all the new shiny tools that you have no experience on. And this is very risky because usually these tools, you have no experience with them, so you will make mistakes. And the new modern code base will become a legacy as well because you don't master these tools. And worse, sometimes the new shiny tools don't last, especially in the JavaScript ecosystem. There are so many web frameworks now that some of them have become deprecated. So at some point it was shiny, so you put it everywhere in your code base, and then it's not shiny anymore. It becomes unmaintained, and then it becomes a legacy. So that's a risk. So I think that's that's a few examples of reasons why I think rewriting everything is generally not a good idea. Do you have maybe other ones in mind that I may have forgot?
No, I agree. And in general, I will just add that I think, I think every developer think that they are the best, and so they can do better than what has been done in the past. I think it's everyone is like this, but I think that sometimes a developer doesn't stop to think that the code base that they want to replace maybe was built over 5 years or 10 years. So it's crazy to think that you can redo that in 2 months. And if you will stop and think about that, you will realize that, maybe it will, maybe I'm twice as good as the previous guy. So it means that instead of taking 10 years, I can do that in 5 years. Still not a good idea.
Yes, I agree. Overconfidence can lead to underestimating the work it actually takes to build such a big system. I totally agree with you.
Yeah. And if I remember correctly, one of the things that you suggest to retain control is to start documenting and securing some parts of the code base. But one challenge that I see with this is that sometimes it's difficult to figure out where to draw the line, because if I have to deal with a very large code base, if I get over enthusiastic, I could spend the next 6 months maybe documenting, adding tests before I add a new feature. So do you think is there any guideline to figure out when enough is enough, when you can move to adding features and stop this initial, let's say, preparation of the code base?
Yeah, I think it's definitely a trap that we don't want to fall into. Start randomly fixing everything. It's tempting, but we must resist. I think the right way to decide, I mean, after, as we said before, after setting things up, starting and deploying, the next things you want to fix are the parts of the code that need to be changed. And by need, what I mean is what is the next bug fix or feature that we want to add, and what are the foundations of that bug fix or that feature. For example, if you're gonna have to add a feature that relies on database transactions, and so far your database is so old that it's not possible to do transactions. At some point, you know that you need to move that part. You need to evolve that part first. And maybe the templating system is rotten, but it's not the right time. I mean, you don't need to fix that in order to implement the feature. Implementing the database system is more important. It's critical to make the change that you need to make. So I think my advice is following the roadmap. What does the client or company wants to do next? What do they need to do with the code base? And based on that, you can make a plan of what do we want to modernize first. I can give an example. I think it was the one cited on the article we talked about earlier. In that article, if I remember well, the project was a data pipeline that was used to feed a machine learning model to how do you call it? Yeah, for the learning of that model, you need to put some data into it, right? And the problem was that when you start a learning session, it takes several hours. And the problem was that after 1 or 2 hours, sometimes it will be interrupted with a type error, like something is undefined, blah, 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 and it stops the entire process. And this is particularly problematic for processing that takes hours to complete and that you run overnight. So you don't watch the process. You just expect it to work when you go back to work in the morning, right? So you don't want it to fail. You want that if there's an error, and especially a type error, you want to discover it at development time. You want to be warned beforehand that something is incorrect in your code. So in that case, probably the things that we want to do is to prevent that particular error from happening. The things that we want to modernize is type error detection. So it means probably we want to renovate the types. We want to enforce stricter rules about types so we can detect these problems before they happen in production. So that's a particular example of what to prioritize. So it really depends on what's on the roadmap and what is the most critical problem that the business wants to address.
I think what you mentioned is very interesting because you're mentioning adding type safety, and I think JavaScript is a very special case because you can sort of migrate to TypeScript incrementally. So it's like you can have a language migration little by little. So that's a very fortunate case. In our job, one of the things we do is migrating from different languages that are completely separate, like for example, from RPG to Java. So in that case, we don't have the advantage of the incrementality. Like, I mean, yes, you can divide maybe the application in module, but you cannot have half of the application, half of a module in RPG and half in Java. So that I think it's an interesting advantage. But I was wondering if you can use this incremental approach also, if you have experience of using that also when maybe doing a very big change, like changing framework, do you think it's still possible to have an incremental approach, or one has to accept it that now for a while you need to stop, pause everything, change framework, take a while, and then...
In the general case, I don't know, but I know that in some cases it's possible. For example, if you want to change your database abstraction layer, it may be complicated, especially if you have like transactions. It may be complicated to do incrementally. It really depends. So again, I don't want to generalize, but if you want to change, let's say your web, your HTTP server framework, this is not that hard because usually when you developing a HTTP server, you have several endpoints, and you can always split these endpoints between two servers, and then have a proxy in front of them that distributes the calls across the two servers. So in that case, it should be pretty easy to progressively migrate the endpoints from the legacy server to the modern server. So yeah, sorry for the disappointing reply, but I think it really depends of the kind of framework. In some cases, I think it's easy with a little bit of, if you have a plan, you have an idea on how to route from the legacy to the modern implementation. In other cases, it's more complicated.
Yeah, no, but that I think it's a very good example and makes a lot of sense. Good. Thank you. And okay, if we wanted, this was a technical challenge, combining and dividing an application in different parts. But something that I would be curious to hear from you is, based on your experience at Shodo, do you encounter roadblocks that are non-technical, like, I don't know, due to the mental approach or maybe the attitude of people? So have you seen non-technical problems affecting these legacy modernization projects?
I think the most usual problem is, as I said earlier, sometimes the decision makers, what we sometimes call the stakeholders, so the C-level directors, whatever, they don't understand the problem of legacy code. They don't understand the concept of tech debt. There can be many reasons for that. And if they don't understand it, they don't want to waste development time fixing these issues. So, and this could come from two problems, for example. Like in some companies, they want to ship as many features as possible. So they just want to run all the time, basically. And as soon as you ask to rework something, to work more efficiently or more safely, they would reply something like, "Oh no, we don't have time. We have to ship this and that. So we'll do that later." And the irony of that situation is that if you remain stuck in that state, it's very likely that you end up spending a lot more time than you should on developing the features, because the code base is very complicated to handle. Whereas if you had invested some time in reworking the code base, you could be much faster developing the features. But it's a complicated point to make, especially as developers. We are used to speak about very technical subjects. So it can be complicated to vulgarize and to explain clearly in non-technical terms what problems we are facing and what are the impacts for the business and for the velocity of the development process. And I think that's one of the reasons why sometimes the block is a human one rather than a technical one. It's just a matter of having the development team able to express the problem in a way that is clear enough so that the decision makers can invest some time in recovering or in reworking the code base. And I think maybe there could be another thing. One reason also that could be a lack of trust. For example, and this can happen if you have a team of developers that are very excited about, or that have very strong opinions about everything. I'm trying to create a, how do you call that? A stereotypical developer. Like, it doesn't exist. It's not that's that bad usually, but let's take a developer who is very opinionated and that want to try all the new technologies. Such a developer may spend a lot of time complaining about, oh, we should use this, we should do that, etc. And if you complain all the time like this, at some point, the stakeholder will stop listening to you. And they assume that you're always complaining. So they ignore the complaining and they just ask you to do whatever they want to do. So whatever the product team or the stakeholder wants you to do. And I think it's a very bad position to put ourselves into as developers. We have to pick our battles. It's very important to, many things are frustrating in a software project. That's usual. And many things are tempting. But if you ask for all the things, you are probably getting none of them at the end of the day. So it's better to pick one, and to pick one that has the most impact. Even if it's just an estimation of impact, you have to pick one and say, okay, we can do all these features, but if we do that little job of reworking the code base, everything else down the line will be faster. So we should do it now. So that's one example of a block that could come from a lack of trust caused by maybe an overzealous developer. So we have to watch our behaviors with non-developers when we try to convince them.
This, I think the point of trust is really a crucial one. It makes me think to the relationship that I have with my mechanic. So when he suggests, oh, we need to do this or that, if you trust your mechanic, say, okay, you mentioned a few things, I have no idea what you said, but I know that you are not a guy that just overcharged me for crazy stuff, so I will trust you, go ahead. While if you have a mechanic that want to change the same pieces every 6 months, maybe after a while you say, yeah, you know what, the car is good as it is, so let's let's avoid that and just do the bare minimum that is necessary. So
it's a good analogy. And I think one common point with the car mechanic, I think the trust can be created if the car mechanic or the developer is able to tell, what if we don't solve that problem? We could solve that problem. I propose to solve that problem. And if we don't do that, this is what may happen. But this is what risk we're talking about. And sometimes the risk is okay. If you're a car owner and you say, okay, maybe, I don't know, my car will not go as fast in 6 months from now because I didn't change that part. It's not the end of the world. I can bring it back in 6 months, But if you are a different person and you need your car to work very reliably, you don't want to go back to the mechanic 6 months later. So you will say, please change the parts. I need reliability. So at the end of the day, what matters is that the car mechanic and the clients are aligned. They find a solution that works for the needs of the clients. So this means that there must be some communication about the requirements and the risk of both people. And if you only use technical terms, the communication cannot happen. You need to talk about, like, if you're a developer, you need to explain the business risks, not the technical risk. Because somebody who has no development knowledge, they don't know what it means. If you say, the database technology is legacy, so then after that we cannot upgrade or whatever, somebody who doesn't know about development, they don't understand how this is a problem, you know. But if you say it that way, if you say, we are not going to be able to install security updates, so there is a risk that we are hacked and that we leak private information, and that we are attacked by some clients in the legal action. This is very concrete, even for somebody who doesn't know about code. And usually, as a business, that's something you want to avoid.
Well, you mentioned the importance of explaining, and one of the services you offer at Chodo is coaching and workshops. So I wanted to ask you what kind of topics you cover and what kind of things that they call, maybe students is not the right term, but the people attending the workshops are typically the most surprised about.
Probably in terms of, I can give one example with a lot of surprise. It's something that we did for one of my clients who was an e-commerce company. They had to rework the invoicing system. And we realized that, at least at that stage of the company, they wanted to get things the right way on day one instead of reworking all the time, because it has legal implications. If you do invoicing wrong, your clients may attack you juridically. So what we ended up doing, with the help of a friend, Julien Topsu, I say hi to him if he's listening, we organized event storming. It's a technique from Alberto Bandolini, who consists of inviting developers, but also people who are not developers, but who are domain experts. So in that case, we had the head of finance from the company who joined a session. And the goal of that session was to draw or to use post-it notes, on a very big wall. We had to show the diagram of what happens in the life cycle of an invoice, from creation, edition, creating modification of that invoice, etc., and all the consequences of these events. For example, whenever you update an invoice, you need to resend it, both to the client and to the invoicing part of the company, for the financial records, etc. And there are certain rules to respect in order to be in accordance with law. So the aha moments, I think, were on both sides. The head of finance was very impressed by seeing the complexity. I mean, she knew the legal obligations, but she had not realized all the things that can happen with an invoice, because the developers did bring some examples that came from real case scenarios. And on the other side, the developers were also surprised by some interventions of the head of finance, who said, "Oh, you cannot do that, guys. You cannot just update a little thing in the invoice. As soon as it's shared with the clients, you cannot change it. You have to reissue a new invoice, and that's how it's supposed to work, So there were several aha moments. But I think the biggest one was afterwards, after months of developments, because this was used then to remodel the invoicing part of the software. And it was done in domain-driven design based on that event storming session. And after that, the development team was delighted. They say, now we are not lost in the logic anymore. Everything is very clear. Whenever we need to change something, we know exactly where it is. When we make a mistake, we are warned by the IDE because of tests, because of types, because of value types, because of all the things we put into place. So I think the biggest aha moment was at that point.
Nice. And I guess maybe developers didn't have the opportunity to speak with the CFO or head of finance every day, so it's been a very good opportunity to take advantage from.
Yes.
And I'm looking at my questions because I think we cover a lot of points, and some of my questions you have already answered them. But maybe one difficult question that I have is this: do you see any characteristics in project that require you to adapt your approach? So maybe is your approach, we'll say, different if the code base is very large or it's very small, if the team is large or small, or if maybe the domain is critical, maybe like finance or another domain? Do you see any characteristics that have an impact when dealing with legacy code, or would you say that these characteristics, these techniques are general and so apply irrespectively of this of any characteristic?
I don't think I have a general technique that applies everywhere. Usually, the clients contact us because they have a problem. The problem can be, look, my server is crashing all the time. We don't know how to fix that. But every time we make a new feature, it breaks something. So that's one example of a problem. Another problem may be, oh, look, one of my developers, like my lead developer, or the one who has been with us for the most time, is going to leave because working on that code base has become too much of a pain, and nobody knows how to reduce that pain. So that could be one other example. Like in these two cases, you're not going to do the same things. So to me, when you start working with a client as a tech coach, you're in problem solving mode, like a developer, but instead of solving technical problems, you solve the problems of a team or the problems of a company. So you need to find what is the root cause. Like you need to find what is the problem, clarify the problem, clarify the impacts of the problem in terms of costs, in terms of risks for the business. And when you have that, you dig down to find the root causes. For example, if a developer is thinking about leaving, you're trying to understand what is so bad, like which part of the code base is particularly hard to maintain, why. So you try to understand that, and then you propose a plan to fix the situation. And I don't remember. Of course, there are some things that I very often used during my missions, like for example, adding stricter type checking in JavaScript. Not the code base. It's pretty usual that I need to, at some point, help them migrate to stricter TypeScript. But that's not always the case, and it's not always the most critical thing to do. For example, one of the missions was for the case of the developer who was considering to leave the company. One of the reasons why was there was an internal applicative cache in the code base that whenever you started the server, it will load data from the database. It will make some processing on it, like computations, aggregation, etc. And then it will store it in memory. And a lot of the code will rely on that cache instead of sending requests to the database. And for a while, it was okay. But as soon as you wanted to scale up that application, then it becomes a problem because you cannot share the memory between more than one instances. So they started putting a Redis instance. So it means that now they had to synchronize the changes between two instances. So yeah, it had become a nightmare pretty quick. So when I started working with that company, what we did is to define a plan of how to get rid of that cache. So in a nutshell, the plan was to really rely on the database. And if we still needed to have some caching for performance reasons, we would use HTTP caching instead of data caching inside of the Node.js process. So this has many advantages. It simplifies the code a lot. It removes all of the complexity of having to synchronize things between systems. But it was hard to do because then you had to untie the features with that cache. And that's actually in that project that we had to need to use the AST approach. This was one way to track wherever that cache was used in the code base. And the bonus of that approach is that you could use it as a way to measure your progress. Because basically we were counting the references to the cache, and the goal was to reduce the number of references to that cache. So let's say at the beginning we have 300, and 2 weeks later we had 280. So it was easy to follow the progress of that project and to know exactly when it was finished. And this mission took a while, but the objective, the goal was reached because the developer is still working for the company, so he didn't leave. So
there's an happy ending.
So yeah, it worked, and yeah, and now the dynamic of the team is healthy now. They are able to ship quickly and safely. And everybody is still very happy to work for that company. So I think the company made the right choice to ask for help to solve that situation. I think it's an investment because I stayed there as a consultant for 1 year and a half, I think, which is a lot. It's a lot. It's a big investment. But I think it's worth it because at the end of the day, you have developers that work in great conditions. Business risks are much lower now. The risk of crash, etc., is low because everything is healthy in the code base, and developers enjoy working there. So it's unlikely that they leave the company. Because having a developer who leaves the company is very costly. Yes. Usually you want to avoid that, except of course if it's somebody who is not skilled enough or somebody who is toxic or something like that. In that case, it's better to say goodbye. But in most cases, you want to keep your developers.
Now I have a bit of a different question, something that I'm forced to ask because of the era in which we are, which is about AI. So I'm happy that we managed not to mention AI too much. We just mentioned LLMs in the beginning. So, but I wanted to ask if you have seen possibilities to use AI for legacy code modernization that are maybe overestimated or underestimated. So if you notice something that was a surprising, interesting usage, or maybe if you have seen people trying to do something that in practice doesn't work with AI. So if you found any surprise about AI and legacy code.
My experience with AI, LLMs like Copilot, Cursor, etc., is still pretty recent. I mean, I really started working with them for 1 year and a half or 2 years, something like that, and with very small steps. But I do have a first-hand experience with it. I think that it's very powerful for some cases. For example, I remember at some point GitHub had released Copilot feature that was able to write tests. And at that time, I was still working for Shodo, and Shodo is a software craft community. So we were like, oh my God, don't let a computer write tests. It's not a good idea, you know. But I mean, we tried it anyway. And yeah, the tests were not perfect, but that's not my point here. The thing that was, I think, very powerful is that I found a very old function I wrote 10 years ago, and I had no idea what that function was for. I forgot why what that function is doing. So I asked the AI to write a test for it. And the great thing is that the test gave me some inputs and outputs for that function, which helped me understand what the function was for. If I had to write that test myself or to re-understand that function, it would have taken me probably half an hour, maybe 1 hour, I don't know. Here, in 10 seconds, I had a test that informed me about the meaning and the usefulness of that function. So yeah, I think in these cases, like to understand the code, LLMs are quite interesting. So yeah, I think they can help us a lot. Another example is when you discover a code base, legacy or not, by the way, doesn't matter. You want to find the entry points, for example. Given that your tool has a context window that is big enough, or that it's able to do several requests to browse the code base, it did help me find the entry points of that software. And then even better, I was able to ask it to generate a sequence diagram of some of the endpoints. So the AI will dig deep into the code base to find the code path of each entry point and draw a mermaid sequence diagram that I was able to put in a markdown document in GitHub. And this, it did it in 10 seconds. So I think LLMs are very powerful to save us time to understand legacy code bases. At least I only tried it on JavaScript code base. I don't know how it's going to behave on COBOL or in older languages, but I think this is a powerful use case for it. If I want to give a not so good example, I recently tried to use LLMs to migrate. I mentioned earlier the abstraction layer to a database. This is actually an example where I think the LLMs were not good enough at that point. It's in an open source code base that relies on MongoDB for storage. And it was using a very old driver, a very old MongoDB driver that relies on callbacks, which is a very old way to write JavaScript. And the latest versions of that driver do not support callbacks anymore. So you had to migrate all the calls into promises. And I don't know how familiar you are with that, but it's not hard to change a callback into a promise for one call. But if your logic is very old and legacy and buggy, then it's quite complicated quickly. And there were calls all over the place in the code base. And for this use case, even with an agentic approach where several requests were done one after the other, I realized that the LLM, after 2 or 3 iterations, will drift into making changes that became irrelevant for the task and even started breaking stuff. So I was hoping that I could delegate that migration to the LLM. I would have loved that, like the vibe coding of legacy fix. That would have been great, but it didn't work as good as I hoped. Maybe there is a way to do it, but as of today, I've still not found the right way to do it. My guess is that if I wanted to do it again, I will need to have a more controlled way of prompting the LLM, giving it more structure, or maybe taking control of the iterations. For example, I will say, okay, do the migration just in that file, and that's it. And don't update this function or don't take these liberties. We just want to replace callbacks by promise. Stop. Like being very strict about the scope of the changes you allow the LLM to do. That's probably how I will do it if I were to try this again. What about you? Have you had experiences with LLMs on the legacy code?
Yeah, no, I would say my experience is similar to yours. So we are using it to understand code bases that we are not familiar with. So if someone throws at us a code base of 5 million lines of code, then we can generate summaries, but we use a mix of AST techniques with LLM. So for example, I can parse a file, recognize a function, then I find this function and say, okay, analyze this code. Well, we do that with traditional techniques like analyze this code and find which other function it's calling. And then we use the function for which we want an explanation and the related function to build a prompt. And that, so we created, let's say, the right context to avoid the problem that, if we try to throw the code base at the LLM 5 million lines of code, but we cannot. But if we are able to figure out which part to throw, then it seems to work decently. We did a very small experiment with test generation also, but because the problem that we are facing is that when you translate an old code base to a new language, maybe you translated, again, 5 million lines of code from RPG to Java. Then you have 5 million Java code with 0 test. That is not ideal. So we are experimenting with generating tests for that because, but when I try to do other things like, let's try to do this huge refactoring, then, Cursor or the others, tend to get lost. Then I get upset and then I spend half an hour insulting Cursor. This doesn't help. So
I agree. For refactoring operations, I think it's still safer to rely on our IDEs. I mean, with good old algorithms, that are probably AST based, it's safer to do. There are tools to help you do that. I know that Nicolas Carlo has done many of them for the JavaScript community. So yeah, I think it's a matter. LLMs are powerful. It's just one more tool on the shelf that we can use. It's good to know for which use cases it's good, and for which use cases it's not good enough at that point. But it's progressing so fast. I think we still need to keep an eye on it, on all the evolutions that are coming on the LLM world, because it could be a huge time savers in some cases.
And we already took more than 1 hour of your time, so I will skip the many other questions. But maybe one final question is there any other resource that I didn't mention that one can use to learn more about your work and what you're doing at Shoto?
If I may start by, I'm not working for Shoto anymore. It was maybe two years ago that I quit. It was more the reasons were more tied to the market, the state of the market at that time, to be honest, because I loved working there. But since then, I've been developing in startups as a developer, and I still have some challenges with technical debt and legacy code. So I'm still practicing this. To answer your question about authors and resources, I think Adam Thornhill is a great author on that topic. Also, Michael Feathers He wrote a book. I don't remember exactly the title, but it's I think it's How to Deal with Legacy Code, which is a kind of Bible for people working on legacy, in my opinion. Also, I wanted to mention another author that I met in one of Nicolas Carlo conferences. I think she's called, I always forgot her name. I feel so bad for that. I think she's called Camilla Lilienthal or something like that. And she had given a talk about how to change, like to do refactoring, but at a very high level, at the modular level. Like you could move a file from a directory to another directory based on the links that you could see graphically in the code base. And you could see all the cyclical dependencies, for example, from a module to another module, and then you can move things around to get rid of these cyclical dependencies. I will share the link to that talk with you if you want to include it.
Add it.
And it's not Camilla, it's Carola, I think.
Oh.
Maybe I can find it now. Yeah, Dr. Carola Lilienthal. I will send you a talk about her.
Perfect. Sounds interesting. And well, what can I say? Thank you very much, Adrien. A lot of content to unpack. Sorry if I took more of your time that we planned, but there were a lot of interesting things to cover, and I really appreciate it. So thank you.
It was a pleasure. Thank you for the discussion, Federico.